Lesson number 113 is about direct and inverse variation. Let's start off by looking at our first problem. The mass of a substance varies directly as the volume of the substance. If the mass of 2 liters of the substance is 10 kilograms, what will be the volume of 35 kilograms of the substance? Now, what we know is that this says varies directly. And in order to solve this, we need to know that varies directly means as one thing goes up, the other thing goes up. Or if we look at it in the opposite way, if one thing goes down, the other thing goes down. That means varies directly, up and up, or down and down. So in this one, there's a couple different ways we could solve it. One way would be to use a proportion. If the mass of 2 liters of the substance is 10 kilograms, so 2 liters is 10 kilograms, we're setting up our proportion. What will the volume be if we have 35 kilograms? 35 kilograms. What will the volume be? How many liters do we need to have here in our numerator? What would you do to solve this? Perhaps you said use cross products. If we did that, 2 times 35 is going to equal 10 times our question mark. 2 times 35 is 70, so 70 equals 10 times our question mark. Our question mark, that is our volume, V, is going to have to be equal to, well, 70 divided by 10 is 7. So 7 equals our volume, so it must be 7 liters as our answer. Now this is one way we can solve the problem. In this lesson, we're going to look at another way. The other way we're going to look at to solve this problem is to use direct variation. Direct variation here. We'll look at inverse variation shortly. Direct variation, what that means is the mass of the substance varies directly as the volume. So as the mass goes up, the volume goes up. And the way we're going to write that is the mass of the substance, M, varies directly equals K times our volume. The mass equals K times our volume. K. K is called the constant. And technically, it's the constant of proportionality. What the constant of proportionality K means is what do we have to multiply our volume by, K, in order to get to our mass? And let's look at how this works. The mass of 2 liters of the substance is 10 kilograms. So 10 kilograms, that's our mass, equals K times our volume, 2 liters. So we can figure out K really quickly. 2 times 5 must equal 10. So K is equal to 5. That's our constant of proportionality. Now, that's an important piece, so we'll underline it. The problem says what will be the volume of 35 kilograms of the substance? So if we have 35 kilograms of the substance, well, 35 is going to equal K is 5. K is 5 times our volume V. So what do we need to multiply 5 by in order to get to 35? The volume V must be 35 divided by 5, which is 7. We get the same answer here. So I'm going to write that with a label, 7 liters equals volume. We just solved it a different way. Now you get the same answer either way. But using this constant of proportionality is really nice because once you know the constant of proportionality, you just multiply, in this case, your volume by that number, 5, in order to get your new mass. Whereas if you use proportions, you've always got to use cross products from the beginning to solve. The constant of proportionality helps us get ahead a little bit in future problems. Let's look at some more. The distance traveled by a car at a constant speed is directly proportional to the time spent traveling. If the car goes 75 kilometers in 5 hours, how far will it go in 7 hours? This problem says directly proportional. That means as one goes up, the other goes up. The distance traveled, D. Distance is equal to K, our constant of proportionality, times the time spent traveling, so times T. Distance equals our constant times T. Now let's solve for this one. The car goes 75 kilometers 75 is our distance, equals k times our time, 5 hours. We can easily figure out what our constant k must equal. K must equal 15. So k equals 15. That's an important piece. Because if we know k equals 15, the distance traveled will always equal 15 times whatever our time is, given this information. So how far will it go in 7 hours? The distance equals 15 times our time of 7 hours. 15 times 7. 15 times 7. What must that be equal to? The distance must be equal to 105, and in this problem we've got kilometers. So we've got our final answer. You go ahead and box that and move on. Again, we could have used a proportion to solve this, but we could also use this directly proportional relationship where we have distance equals our constant of proportionality times our time in order to find our answer. Under certain conditions, the pressure of a perfect gas varies inversely as the volume. Inversely. As one goes up, the other goes down. When the pressure of a quantity of gas is 7 pascals, the volume is 75 liters. What would be the volume if the pressure is increased to 15 pascals? Now, direct variation as one goes up, the other goes up, means we multiply. So in this case, if we have inverse variation where one goes up and one goes down, must mean the opposite. It must mean that we have to divide. If we have to divide, this one says the pressure of a perfect gas, pressure P, varies inversely as the volume. So instead of multiplying our constant of proportionality times what it's related to, we're going to divide. And we've set up our equation. Now we have to substitute to solve. The pressure of a quantity of gas is 7. 7 equals our constant of proportionality K. That's what we're going to solve for first. The volume is 75 liters. So in order to figure this one out, what K is equal to, we need to multiply 75 times 7. Let's work that on the side. 7 times 5 is 35. 7 times 7 is 49, plus 3 more must give us 52. So we've got 525. K, our constant of proportionality, must equal 525. Now that's an important piece. It's not our answer, but it tells us what our constant is so we can solve for the next piece. What would the volume be if the pressure is increased to 15 pascals? So the pressure goes up to 15 from 7. That's going to equal K, which is 525, over our volume V. Now, if we want to find our answer, we multiply both sides by V. V's cancel, 15 times V. And then we'd have to divide both sides by 15. So V is going to equal 525 divided by 15. Please pause the video now to find that answer. I'll pause with you. Alright, if you're ready for the answer, here it is. The volume should have equaled 35. And since it's volume is measured in liters, so volume equals 35 liters. And we've got our final answer. Now, for direct variation and inverse variation, we need to have some general formulas that we can use. Direct variation is always going to look like a constant being multiplied by a value to get another value. So, since we have multiplication, we could write it as V equals K, our constant, times W. V could mean volume, it could mean anything. Okay? It's what comes first before we say direct variation. For inverse variation, we could say V equals inverse, as one goes up, the other goes down, it's going to be K, divided by W. We like to use a lowercase for K because it tells us that it's a constant that we need to solve for. Now looking at these with pictures, direct variation could mean as one goes up, the other goes up, or as one goes down, the other goes down. Inverse variation means as one goes up, the other goes down. Or it could mean as one goes down, the other goes up. So we've got these relationships to help us solve. Our lesson practice will be on page 477. We'll practice this more. Make sure you've got your notes complete, and I'll see you in our next class.